All right, friends, I'm going to go through the introduction to LT5A. So if you need to, go to Google Classroom and download this PDF. So LT5A is word problems. We're doing math, calculations. So a couple equations for you. One, just a reminder that F net is the sum of individual forces. I don't use that equation a whole bunch. It basically is saying like we're going to use these F net X, F net Y equations. Second equation, the net force is equal to mass times acceleration. We know that equation. Third one, Fg equals mg. So we haven't used that one in a while, but that is weight is the force of gravity, and that's equal to mass times, on Earth we use G is equal to 9.8. So we'll use those equations to solve these problems today. So the first three are just single step problems. So what is the force of friction acting on the car if the net force is negative 10,000 newtons? So I'm going to write down an F net X equation. So I would say Fp minus the force of friction, right? I always do right minus left, and then Fn minus Fg. Since it's not accelerating up or down, this is equal to 0, but we do know this one is not equal to 0. So we can set it equal to ma if we want to. And they're asking me for the force of friction. So I look at my equations and I say, I'm going to use this equation, that the pull force minus the friction's equal to that net force, which is ma. So I'm going to plug in variables. Pull force, they're giving us in the picture, 7255 minus the force of friction is equal to, now I don't know the mass or the acceleration, but I do know the net force is negative 10,000 newtons. So we're not going to use mass times acceleration, we're just going to use the idea that we know the net force. So then I need to calculate that. I'm going to let you guys calculate that on your own. Let me grab my calculator. So what I get, so I add 10,000 to both sides. And so what you get is 17,255 minus the force of friction is equal to 0. So I add the force of friction to both sides, and so the force of friction is 17,255 newtons. And for direction, I'm going to look at my picture. Friction's to the left. All right, so I have solved for my force of friction. Let's try number 2. An 800 kilogram motorcycle begins slowing down at a rate of negative 0.75 meters per second squared. I'm going to circle that. That's my acceleration. It says, what is the net force that is exerted on the motorcycle? So I'm given the mass is equal to 800. I'm given the acceleration is equal to negative 0.75 meters per second squared. Oh, sorry, I forgot the 7.5. And I'm looking for the net force. So on the last problem we were solving, we had net force, but I used an F net X equation. On this one, I don't have a free body diagram. I don't have a net force equation, but I do know the equation F net equals ma. So there's multiple ways that you can use that net force equation. So I'm going to set my mass 800 times my acceleration 0.75, and I'm going to get that my net force is equal to 600 newtons. I don't have a direction here. Oh yeah, I do, because this is a negative acceleration. I almost forgot that, friends. So my net force, if the acceleration's negative, we know that means my net force is negative. Glad I caught that. All right, let's try the third one. What is the mass of an 803.6 Newton person? So this would be like if an 800-pound person, a big person, right? It's not, but when I say an 803.6 Newton person, I'm telling you the Fg, or the weight of the person. So that wording, when it's worded like that, it's telling you the weight. So I'm trying to find mass, and I know Fg. Mass is equal to question mark. Fg is equal to 803.6 newtons. What equation do I have that relates those two? Well, that's my Fg is equal to mg equation that we learned a long time ago. So Fg is the weight, 803.6. Mass is what I'm looking for. G on Earth, we want to write it down, is always 9.8 newtons per kilogram. So I'm going to put a 9.8 there. Divide both sides by 9.8. 82 kilogram mass person. That's a fairly average size person. Okay, if you need to rewatch any of those, pause the video, rewind. That's the best part about a video, and go back. I'm going to go on to some multi-step problems. So here our problem-solving steps are outlined for you. We always have those. They're the same as Unit 1, but basically it's, what are you solving for? Draw a picture, list what you know, pick an equation, match your information, and then solve. So let's try number 1 together. A 1,000 kilogram SpaceX rocket. So that is mass, because it is in kilograms. So if you want to label it, you can do that. It's launching into the air with an increasing speed. That's going to be important. While the rockets provide an upward force of 250,000 newtons. What is the net force of the SpaceX rocket? Draw an FBD, write out net force equations. So similar to our explanations, we're going to start with an FBD. So I have a rocket. It's launching into the air, so it probably isn't on a surface, but it has weight, and it also has a push force pushing it upward. That's what this number is here, 250,000 newtons. Since it's increasing speed going up, I'm going to make that arrow longer. So the FP up is bigger than the force of gravity. It's moving up and speeding up, so these two are both going up, and that means the net force also has to be up. So in the x direction, I have nothing. F net y would FP minus FG is equal to MA. So I don't set that equal to 0 anymore. I can set it equal to my mass times my acceleration. So the question says, what variable are you trying to solve for? So these are the questions you're going to ask in your head normally, but since we're learning how to do these, we're going to put them on paper. So what are we trying to solve for? It says I'm trying to solve for F net. Write out your knowns you can determine from the question. Well, I know the mass is, was that 10,000? Yes, 10,000 kilograms. I know the push force is 250,000 newtons. And I think that's all I know, right? What equation will I solve for this problem at the end of the day? So I'm going to need to do a couple calculations. This is saying like, all right, in order to find net force, what eventually am I going to solve for? Well, I can do that 2 ways. I can solve for net force by subtracting these two, or by doing mass times acceleration. Looking at what I'm given, I don't know acceleration, IDK. So I'm not going to use mass times acceleration. Instead, I'm going to use this portion of my F net equation. So I'm going to use the equation F net y is equal to FP minus FG. I'm not going to use the MA side because I don't know A. Now, what other variable do I need to solve for first in this equation? Well, I know FP, that's given to me, but I don't know FG. So how do I solve for FG? Well, I'm going to do MG. I know M and G, so that's going to work. So this is a 2-step problem. So first I need to calculate FG. So take the mass, 10,000 times 9.8. So your weight, your FG for this rocket is 98,000 newtons. Now I can use that equation I wrote here to solve for the F net y. So F net y is equal to FP minus FG. So that's what I'm solving for. FP is 250,000 newtons minus 98,000 newtons. Grab my calculator. That F net y is 152,000 newtons. Okay, so that was a 2-step problem. I had to first solve for FG, then plug it in to solve for F net y. That's what makes these problems a little harder. Let's do another one. Again, you can always pause this video and rewatch if I'm going too fast. Problem number 2, in a 117,600 Newton plane speeds up from rest on a runway. The plane engine exerts a force of 70,000 newtons that allows it to accelerate at 8 meters per second squared. What is the force of friction acting against the plane? So again, free body diagram. This plane is on a surface. So when it's on the runway, it hasn't taken off yet. So there's a surface, there's a gravitational force. Since it's on a surface, there's a normal force. Those two are balanced because the plane is not taking off yet. It's just accelerating on the runway. There is a push force pushing the airplane forward, and there is a smaller force of friction. I made it smaller because it said it's speeding up. So F net X would be FP minus FF is equal to MA. F net Y is normal minus gravity, and this one's equal to 0 newtons because we're not accelerating vertically. We're moving to the right and speeding up, so all of these arrows go to the right. So now solve the problem. Again, these are the questions you should be asking yourself in your head. What variable am I trying to solve for? It said the force of friction. So I'm trying to solve for force of friction. What do I know from the problem? 117,600 newtons. That's the weight. How do I know that's the weight? Because it's measured in newtons. Otherwise, they would say kilograms. So I know Fg is equal to 117,600 newtons. Let's see, I know the push force is 70,000. And I know the acceleration is 8 meters per second squared. Those are my given variables. At the end of the day, what equation will I use to solve for the force of friction? So looking at my F net equation, I'm going to use this portion of it. How do I know that? Well, because I know I'm solving for this. I know the acceleration. I know the push force. I don't know mass, but maybe I can do another equation to solve for mass. So I'm going to write that equation here, that FP minus FF equals MA. On your formative and summative, you guys, they're always going to be two-step problems. So it's okay if you have a variable you don't quite know yet. You're going to use another equation to solve for it. So for that equation, what am I going to need? I'm going to need mass. How can I solve for mass? Looking at what I'm given. Ooh, look here, guys. I'm given the weight. Given the weight, I can solve for the mass by using Fg equals mg. I know this, I can solve for this. So that was answering both of those questions, sorry. Fg equals mg is what I'm going to use down here. All right, let's solve it. So I'm going to do that over here. So first, my first step is going to be Fg equals mg. So the weight is that 117,600. M is what I'm looking for, and G is 9.8. So on this problem, I'm dividing by 9.8. So I get 12,000 kilograms. It's a big plane. Now I'm going to solve for the force of friction. So now I'm going to use this equation right here. So the push force to the right minus friction to the left is equal to MA. We know the push force is 70,000 newtons minus the force of frictions equal to 12,000 times 8. So 12,000 times 8, that's 96,000. Looks like Mrs. Rona might have made up a bad problem here. Let's try it. So 70,000 minus 96,000 is equal to negative 26,000. I think I made a mistake, guys, when I made the problem. Let me double check my work. Do I have all my numbers right? So 117,600 divided by 9.8 times 8. Yeah, so I made up the numbers wrong, but that's okay. We'll all survive. All right, so what I want you guys to do is try the problems moving forward. So there's level 1 problems. These are just helping you really get the basics down. Level 2 problems, when you get to those, are here, okay? They give you the steps you're solving. Level 3 problems are the one you're expected to do on the formative, and I think there is a challenge problem, a level 4 problem if you want to try it. These problems are not due tomorrow. They won't be due till next week, so just get as much done in the period as you can. Good luck.